Okay, so this is going to be part 3 and the last part of our videos on inductive and deductive reasoning. This is me saying, this one is shorter, I promise. The last one was not under 15 minutes. I apologize. I got a little bit into logic puzzles. Anyway, continuing on, we're going to look at which inductive arguments do we think are stronger. We have 2 examples here. The first one says, 380,000 freshmen at 722 four-year institutions were sampled, and 25% said they often didn't come to class prepared. There is a 95% probability that 24.84% to 25.15% of all college freshmen come to class unprepared. I hope that's not the case, but that is a conclusion based on technically a set number of specific cases. The next example is, my kindergarten, first grade, and second grade teachers are all women. All teachers are women. Okay, so what makes an inductive argument strong? Out of these 2, which one would you say is stronger? I'll wait about 5 seconds for you to kind of read them over again and then see which one you think is stronger. Okay, I hope that you said that this first example was a stronger inductive argument. And one of the reasons why it would be a stronger inductive argument is because the number of cases is much stronger. Or not much stronger, but greater. So the number of cases is large. Okay, that gives us a sense that our inductive argument would be valid, okay, because you've sampled so many people at so many different places, and you have such a high probability that around 25% between those 2 percentages are unprepared when they go to class. So, large number of cases definitely makes an inductive argument much stronger. This one right here, I would say, is pretty weak because you could have 7 female women teachers in a row, but that still doesn't mean that all teachers are women. Okay, so maybe if all through your entire preschool through 12th grade, and then you come to college and all your professors were also all women, then maybe it'd be fair to say that all teachers are women, but we know that that's not actually the case. So what makes an inductive argument strong? If there's a large number of cases, and honestly, anytime you have a large quantity of cases, it's going to increase the strength of your inductive argument. There might be other things that you might consider makes an inductive argument strong, but I think that this is the number one thing that makes it a strong case. Okay, now here's our challenge. We're going to look at a couple of number tricks. Okay, and in the number tricks, we can use inductive reasoning, but then we could also use deductive reasoning to show that this is always true. So we're going to consider the number trick below. We're going to select a number. So I'm going to pick a number. You're going to pick a number. I might pick 2 numbers. And then you're going to pick a number, okay? And you're going to see if we can come up with what's going on. So I'm going to select, for the first one, I'm going to select the number 11. Okay. For the second number, I'm going to select 4. One reason why I'm picking different values, like one's odd, one's even, is to kind of see if I can figure out what's going on. So on that original number, I'm then going to add 5. Okay. So 11 plus 5 is 16. 4 plus 5 is 9. Okay. Then I'm going to multiply the result by 4. Well, 16 times 4 is 64. 9 times 4 is 36. Okay? If you can't do that computation on your own, you can use your calculator to do that, but I'm hoping that you get very quick with these kinds of quick computations. Then we're going to subtract 20 from the result. So 64 minus 20 is 44. And 36 minus 20 is 16. And then we're going to divide our result by 2. So 44 divided by 2 is 22. 16 divided by 2 is 8. Okay, so go through that same process with your number as well. Okay, and then let's figure out what our conclusion is. What is a shortcut to determine the final result based on the original number? Okay, so what actually happened from the first number when I went through all these steps to get to this result? And when I took 4 and I went through all those steps, but I got to this result. And hopefully you did your number and you got to a result. Okay? So hopefully we can see that the final result, without going through all the steps, it just doubles the original, because 11 times 2 is 22, and 4 times 2 is 8, and hopefully whatever number you picked times 2 gave you that final result. So we could say that the original number, is doubled. Okay? So that's using inductive reasoning, though, because we had 3 cases where that might have happened. So then we say the original number is doubled to get the final result, right? But there's a way to actually represent this using deductive reasoning, okay? If I select a number, we're going to select the number n, okay? N represents any number possible, okay? It's not a specific number, it's any number. And then we're going to add 5 to that, so we'll represent that as n plus 5. And then we multiply that by 4, so 4 times n plus 5. Using the distributive property, that's the same thing as 4n plus 20. From there, we're going to subtract 20 from that. So if I have 4n plus 20 minus 20, plus 20 minus 20 is 0, so that just leaves me with 4n. And then I end up with dividing that by 2. Well, 4n divided by 2 gives me 2n. So you see that your general case works every time. If I take any counting number and substitute it into this number trick, I end up with the number doubled. And I'm going to put it on you to try this one below and see if you can do the same thing. I want to make sure you know to go into my math lab and work on the homework associated with this section. The section is 1.1. It's the first homework assignment that's due. I tried to make the lengths of the homework assignments pretty reasonable because of how much we have to get done throughout the entire course of the summer. And there's several questions that are related to understanding the definitions. So some of those hopefully should come around really quickly, as long as you've taken really good notes based on what we've done. Please feel free to email me if you have any questions. If you want to check any of the extra questions with me, that is absolutely fine. And good luck with getting your homework done. Thank you.